In our last class, we discussed the basic terms and definitions of lines and angles. Today we will learn the proof of theorem 6.1 and we will solve the questions given in exercise 6.1. So theorem 6.1 states that if two lines intersect each other, then the vertically opposite angles are equal. Now here you see in the figure that AB and CD are two straight lines and they are intersecting each other at O. So we will get two pairs of vertically opposite angles. The two pairs are angle AOC with angle DOB and angle AOD with angle COB. So they are forming two pairs. We need to prove that angle AOC is equal to angle DOB, also angle AOC equal to angle COB. Now here you see, so AB and CD are two lines. If we consider CD as a line, we can see here OA is the ray standing on CD. So CD is a line and OA is standing on it. Then we have these two angles as adjacent angles and they will add up to 180 degree. That means these two angles are supplementary angles. So we can write the relation as angle AOC plus angle AOD equal to 180 degree. You give equation 1. Again here you see AB is the line. So once we will take CD as a line, OA as the ray standing on it. Again we can take now AB is the line and OD is the ray standing on AB. So we get angle AOD plus angle BOD equal to 180 degree. That gives you equation 2. Now you choose two equations in such a way so that one angle comes common in both the equations. Then since both the equations are equal to 180 degree, so we can equate them as angle AOC plus angle AOD equal to angle BOD plus angle AOD. Now here you see angle AOD is common in both the sides, so we can write now AOC equal to BOD. Similarly, we can show angle AOD equal to angle COB. So here what you all have to see especially that once if you take CD as a line, then OA will be the ray. Then again you don't come to this side on the same line. You again take AB as a line and OD as a ray standing on it. So when you take CD as a line and OA as a ray, you get this angle plus this angle equal to 180 degree. In the second case, you take AB as the line, OD as the ray, so these two angles will add up to 180. In that way, angle AOD comes common. Now, let us see question number 1 of exercise 6.1. So, the given conditions are AB and CD are two straight lines, they intersect at O. Also, it is given here AOC plus BOE equal to 70 degree. Angle AOC plus angle BOE equal to 70 degree. Angle BOD equal to 40 degree. We are to find angle BOE and reflex COE. Angle COE is this one. Reflex will be the angle outside it, this whole angle. So how can we find out reflex angle? Now if an angle is less than 180 degree, then the reflex angle can be found out by subtracting that angle from 360 degree. As we know, the angle around the point is 360 degree. So here let's see the proof now. Now first let us consider CD as a line. Then AB is another line. So CD and AB are intersecting each other. So we can say then that angle 1 and angle 4 are vertically opposite angles. Also here angle AOD is equal to angle 2 plus 3. We can use this statement. Now first here we know that it is given angle 1 plus 3 equal to 70 degree. So here we can see that AB is a straight line and on AB we have two rays as OC and OE. So we can write here as 1 plus 2 plus 3 equal to 180 degree. 1 plus 3 plus 2 equal to 180 degree. I wrote 1 plus 3 plus 2 because 1 plus 3 has been given as 70 degree. So it becomes easier for to replace the values. So 1 plus 3 we wrote 70 degree and angle 2 we will get as 110. Now here you have seen I have given the names of the angles as 1, 2, 3, 4. That is convenient for us to simplify. So what are we getting here? 1 plus 3 is 70 degree. So we put the value here. Then it gives angle 2 equal to 110 degree. Now what is angle 2? Angle 2 is angle COE. Next we can write angle COE equal to 110 degree. Now we have been asked to find out the reflex COE. So what will be the reflex COE? We can see here this angle is less than 180 degree. So to find out the reflex COE, we can subtract it from 360 degree, which will give you 250 degree. So we got reflex COE. Now next, let us see how to find out angle BOE. This is your BOE. Now here we have 1 plus 3 equal to 70 degree. So we can write here angle 1 plus angle 3 equal to 70 degree. Again we can see here angle 1 and angle 4 are vertically opposite angles. So can we say angle 1 equal to angle 4? So in that way, since 1 equal to angle 4, vertically opposite angles, then we can replace this angle 1 by 4, that gives you angle 4 plus angle 3 equal to 70 degree. Got it? Now angle 4 we have been given 40 degree. So we can write here 40 degree plus angle 3 equal to 70 degree. Thus angle 3 comes 70 degree minus 40 degree equal to 30 degree. So your angle 3 will come 70 degree minus 40 degree equal to 30 degree. Then angle 3 is nothing but angle BOE. So last line you can write here angle BOE equal to 30 degree. Then you can underline. Okay. Now next let us come to number 2. In question number 2 we have X, Y and MN are two intersecting lines. They intersect each other at O. So when we have two intersecting lines, immediately we should keep in our mind that we have vertically opposite angles. So which are the vertically opposite angles? If we take B, B is equal to angle NOY and angle C is equal to angle A plus 90 degree. So that we will use later if we need. And the ratio of A is to B is given as 2:3. Angle POY is given as 90 degree. These are all given conditions. We have to find out angle C. Now we will take the ratio, common ratio as X. So we can write A equal to 2x, B equal to 3x, where x is the common ratio. Now we will multiply the common ratio to the original ratio. Then we get A equal to 2x, B equal to 3x. Now let us see here, when POY equal to 90 degree and now we have XY is a line and OP is the ray on it. So can we write A plus B plus 90 degree is equal to 180 degree? Since we are getting here a linear pair. So we wrote A plus B plus POY angle equal to 180 degree. Then A is your 2x, B is your 3x. So we are replacing them and POY is equal to 90 degree. We got the equation. So we have now 5x equal to 90 degree. Then x equal to 90 degree by 5 equal to 18 degree. And now A will be equal to 2 into x, that is 2 into 18 degree equal to 36 degree. And B will give you 3 into x, since B equal to 3x. 3 into x equal to 3 into 18 degree equal to 54 degree. So you got A equal to 36 degree and B equal to 54 degree. Now let us see how can we find out C. So here you see MN is a line, OX is the ray standing on it. So we can consider here B plus C equal to 180 degree, linear pair. On line MN, OX is the ray, we get B plus C equal to 180 degree. Now we got the value of B as 54 degree. So we will substitute B by 54 degree plus C equal to 180 degree. Now 54 degree can be shifted that side. So C equal to 180 degree minus 54 degree, that gives you 126 degree. Let us now see question number 3. So in question number 3, it has been given angle PQR equal to PRQ. That means these two angles, PQR equal to PRQ. These two angles are equal. So we have named all the angles here as angle 1, 2, 3 and 4. Then we need to prove angle PQS equal to angle PRT. PQS, that means angle 1 equal to angle 4, we need to prove here. So here we can clearly see that if we consider ST as a line, QP is standing on ST. So we have 1 plus 2 as 180 degree supplementary angles since they form a linear pair. Similarly, that side we can see 3 plus 4 equal to 180 degree. So we got again two equations. Now we can equate them as both the equations are equal to 180 degrees, so they themselves are equal to each other. So we can write 1 plus 2 equal to 3 plus 4. Now angle 2 equal to angle 3. It has been given angle PQR equal to PRQ, that is angle 2 equal to angle 3. So angle 2 and angle 3 we can cancel here. Then it remains angle 1 equal to angle 4. Then angle 1 is nothing but PQS. So angle 1 is your PQS will be equal to angle 4 where is your PRT. It is written there. So angle PRT. Thus we have proved it. Okay. Next, let us see question number 4. So we have x plus y equal to w plus z. And then we need to prove AOB is a line. Look at the diagram. So AOB, whether it is a straight line or no, we don't know. And we have to prove it. Now we have the angles here x, y, w and z. And the condition has been given as x plus y equal to w plus z. This is the condition. Now what type of angles are x, y, w, z? We can say like these are all angles round a point O. So we can say x plus y plus w plus z gives us 360 degree. Now here we have x plus y equal to w plus z. So in place of x plus y, we will write w plus z. So w plus z plus another w plus z gives you 360 degree. That gives you twice w plus twice z equal to 360 degree. We have taken 2 common. Then 2w plus z equal to 360 degree. That gives you w plus z equal to 360 divided by 2 equal to 180 degree. So when you have got like w plus z equal to 180 degree, then easily we can say that AOB is a straight line, since these two angles are giving you, when summed up, they are giving you 180 degree. So when two angles add up to 180 degree, they form a linear pair. And thus we can say that OD is the ray on AB, and so AOB is a straight line. Next, let us see question number 5. So in question number 5, the condition is POQ is a straight line, ray OR is perpendicular, this is the symbol of perpendicular, OR is perpendicular to PQ, OS is another line lying between the rays OP and OR. We need to prove ROS, angle ROS equal to half of angle QOS minus angle POS. Let us see the proof now. So they have said that OR is perpendicular to PQ. So we can say that this angle is 90 degree. That means angle ROQ equal to 90 degree. Now in the proof we have angle ROS equal to half of angle QOS minus angle POS. So we will start a relation where ROC is involved. So we can write here ROS is involved. So ROS plus POS equal to 90 degree. Since ROQ equal to 90 degree, and you see that PQ is a line, OR is the ray standing on PO. So if ROQ is 90 degree, then ROS plus SOP will also give you 90 degree. Since here angle POS plus angle SOR plus angle ROQ equal to 180 degree, altogether gives you 180 degree. This angle is already 90 degree, So this angle, that is POS angle plus ROS angle, will give you 90 degree. So we wrote the relation here. Now we are shifting angle POS that side, so that gives you angle ROS equal to 90 degree minus POS. Now what is POSC in the proof? ROS equal to POS is there, so we got POS. Now here QOS we have to bring, so that we can bring only from 90 degree. So 90 degree here, you see now this is 90 degree. Now remember, your target is to bring QOS, so we will relate QOS with 90 degree. QOS is the whole angle. So can we write this 90 as the whole angle, this one, angle QOS minus angle ROS? This is your 90 degree. So this angle we will write as this big angle QOS minus the part of it ROS. So we are getting 90 degree. So 90 degree we are replacing with QOS minus ROS. Then open the bracket and then ROS comes this side. There is already one ROS here, so you bring ROS this side, that gives you twice ROS, because we have ROS equal to now angle QOS minus ROS minus POS. We are shifting ROS to our left side, that gives you twice angle ROS, remained angle QS minus angle POS. Then angle ROS will be half of angle QOX minus angle POX. That's all. Next, now we will see the last sum, that is number 6. It is given XYZ equal to 64 degree. XY is produced to point P, and so draw the figure. So we have here XYZ equal to 64 degree, and they said to produce XY to P. So we have produced, remember, XY, so you have to come in this direction, then put an arrow sign, give a symbol of that line segment, and write P here. So this is the diagram. Now if ray YQ bisects ZYP, so here this is your YQ, obviously it will originate from Y, so YQ bisects ZYP. So if YQ is the angle bisector of ZYP, then what you get? You get these two angles as equal. So you can name this angle as 1, this angle as 2. So we can say, since YQ is the angle bisector, then angle 1 will be equal to angle 2. Now this is your 64 degree. Then they asked us to find out angle XYQ. XYQ, that means the whole angle. So if we know angle 1, we can easily find out angle XYQ, because angle XYQ is nothing but 64 degree plus angle 1. Now here you see, since XY has been extended to P, we can say XP is a line, and you can consider YZ as a ray on XP. So we have here angle 1 plus angle 2 plus 64 degree equal to 180 degree. We get here a linear pair. We can write here angle 1 plus angle 2 plus 64 degree equal to 180 degree. So then angle 1 plus angle 2 is equal to 160 degree. You take 64 degree that side, that gives you 116 degree. So angle 1 plus angle 2 is giving you 116 degree. Now we have already mentioned that angle 1 equal to angle 2. So what will be each angle then? Angle 1 will be equal to angle 2 is equal to, we get 116 by 2, that gives you 58 degree. So angle 1 is equal to angle 2 is equal to 58 degree. Now then easily we can find out XYQ. So what is your angle XYQ then? That is equal to, you see here, 64 degree plus 1, angle 1. So as we know, angle 1 equal to, we got angle 1 as 58 degree. So you can write here 58 degree. That gives you 112 degree. So angle 1 we got as 112 degree. sorry, not angle 1, XYZ. So angle XYQ we got as 112 degree. Next they asked us to find out reflex QYP. So QYP we will find out now. That is your angle 2. So reflex QYP we have to find out. Now QYP is your angle 2. So angle 2 we have 58 degree, and since it is not like less than 180 degree, so how will you get reflex angle 2? Reflex 2 will be obtained by subtracting 58 degree from 360 degree. That gives you 302 degree. Then reflex angle 2, angle, now you give the original name, so angle 2 is nothing but XYP. So we can write now reflex QYP, it is QYP equal to 302 degree. Then you can underline. I hope all the explanations are clear to you. Now the writing part I have already given to you, so you can go through the writing part. I think you will understand better. Thank you.